Hi everyone. In the previous session, we have seen about the significance of slip. Okay, so what is the importance of considering the slip, and we have derived the expression which that is a relationship between the slip, frequency of the rotating magnetic field, and then frequency of the rotor. Next we have the types of rotor. Okay. So, there are two different types of rotor. So, one rotor we call it as squirrel cage rotor. So, one type of rotor we call it as squirrel cage rotor, and another type of rotor is slip ring rotor. In this type of rotor, the rotor core is in cylindrical and which is made up of cast iron or cast steel. And all around the periphery of the core, so longitudinal parallel slots are made. So you can just observe here, all around the periphery of the core here, longitudinal parallel slots are made, that is to accommodate the rotor conductors. So here the longitudinal parallel slots are made to accommodate the rotor conductors, and as you can see here, so we have the parallel slots, or so this we consider it because these are made, the longitudinal parallel slots are made to accommodate the rotor conductors, and these rotor conductors are like thick bars of, or which is made up of, the rotor conductor is made up of thick bars of copper or aluminum. And here the two ends of these parallel bars or the rotor conductor, okay, are welded at the copper end rings. You can just observe here. So there are two rings here, and which we call it as copper end ring. So we have two copper end rings, and these parallel bars, that is rotor conductors, as I have already indicated, which is made up of like copper or aluminum. Of course it is a thick bar, and which are welded at the two rings, so, and which is made up of again copper. Since it is like all the bars, all the parallel slots or the rotor conductors are permanently short circuited or permanently it is welded, it is not possible to add any external resistance. So remember, since these parallel bars or the rotor conductors are permanently connected or welded to two end rings, so it is not possible to add any external resistance, especially for starting purposes. So thus the starting torque of this particular rotor, that is squirrel cage rotor, is very small. Okay, hence it produces very less torque. Since it produces less torque or the moderate starting torque, and of course, and it runs with the constant speed, and so it can be used. It can be widely used in some of the applications like driving fans, okay, blowers, water pumps, grinders, lathe machines, printing machines and drilling machines, etc. Okay. Since this arrangement resembling a cage, we call it as, or it is named as squirrel cage rotor. Next we shall see another type of rotor, that is slip ring rotor, or we also call it as face wound rotor. Okay, you can see the figure here, and this is about face wound rotor or slip ring rotor. And why it is named as slip ring rotor means because we have got the slip ring connection. So you can just observe here, and these are the copper slip rings, and since it is the circuit is made with the slip rings, it is named as slip ring rotor. As I have already explained in the squirrel cage rotor, so here also the rotor core has cylindrical and the slots cut around the periphery, that is to accommodate the rotor conductors, right. And here the difference between the previous type and this type is, here the rotor conductors are in the form of copper windings, or these are the copper windings, and they are star connected. So as you can observe here in this figure, so these three windings are star connected, and the other end of these conductors are brought out and connected to the copper slip rings. So as you can just observe here, so we have three copper wire or windings, and the other end of these 3 windings are so brought out and connected to copper slip rings, right. So copper slip rings, and so like again it is connected to, like this is extended and this is again connected to so variable resistance, and this we call it as rheostat through the carbon brushes or through the brushes. So these are the 3 brushes as you observe in this figure. And look at this arrangement. So we have 3 copper windings, and other end of the copper windings are given to copper slip rings, and of course again it is extended and given to the rheostat via brushes, okay. So via brushes, and so in this figure you can just observe, so we have considered variable resistance, or we also call it as 3-phase rheostat. Okay. So rheostat means what? It is again a variable resistance, and remember, like you can just compare this figure with the previous one. In the previous that is squirrel cage rotor, of course it is not possible to add any external resistance that is in series with the rotor, but in this case we can have any external resistance. So we can have any external resistance, especially for starting purposes. So that we can get high starting torque. And this is the details, the construction details of this slip ring rotor, and let us see the working principle of slip ring rotor. And when we come to the working principle of this particular figure, or that is a slip ring rotor, and at the time of starting all the 3 resistance are included. So you can just observe at the time of starting these 3. So these 3 resistances are like included, that means we call it as rheostat circuit is included, and so of course like the resistance value decreased as the rotor picks up the speed. So remember, the resistance value decreases as the rotor picks up the speed, and so gradually like once the rotor comes to the normal speed, okay. So once it is running at the normal condition, so what happens, the like resistance value completely decreases, and at some point so these 3 resistance value, I mean this circuit becomes short circuit, because all the like here when it decreases and when it comes to a very less value, so this becomes short circuited, and all the rings, like so all the 3 connections are joined together. So these 3 connections are joined together. So finally we can get like, so that is so, and especially this particular circuit is used whenever the high torque is required, whenever high starting torque is required, and so whenever we want to control the speed, so we go with the slip ring rotor. And when you look at the working principle of this particular circuit, here we can have any external resistance. That is to control or to obtain high starting torque. Okay, and but in the previous case, that is in squirrel cage rotor, like external resistance cannot be added, since the parallel bars or the longitudinal bars are permanently welded or permanently short circuited. Of course, this is again so widely used in like applications like lifts, elevators, cranes, okay, and compressors, etc. And here all these applications or like all these applications requires high starting torque. Of course, like speed control is also required here. Next we have the necessity of starter, and which is very important in this particular chapter. Okay, and because we have seen the low starting torque and high starting torque in both the cases, that is in both the different types of rotor. Okay, so in the first squirrel cage rotor, so we have seen that because it is widely used in like some of the applications like where we can have less starting torque, and similarly a slip ring rotor we have seen, so and that is used for again the applications which it requires high starting torque. Okay, and what is this starter again? And so remember, this is very important. You need to understand what is the necessity of this starter. Okay, wherever you see, like even in automobiles, so you see like we have a starter. Okay, and what is the necessity of this starter? Especially so whenever we consider this motor operation during the normal working condition of the motor, so it has full rated voltage applied across it. and here if the voltage is applied or the full rated voltage is applied, the motor tends to draw heavy current. So it tends to draw heavy current, and of course which is larger than the rated current, right. So motor tends to draw heavy current which is larger than rated current, of course. So here because of this heavy current, right. So because of this that is inrush of heavy current which damage of course which is dangerous. Why? Because it affects the system voltage momentarily. At the same time it damages the elements, like any elements which are connected to the motor, and of course which causes a voltage drop for all the appliances connected to the line. So remember, which is not desirable. Okay, I hope this part is clear. So why the starter is required means, so here initially, so the motor tends to draw heavy current, that is because of this heavy current. So what happens, of course which is dangerous, and it affects to the system voltage momentarily, and at the same time and it damages the elements which are connected to the motor at the same time. So there will be a voltage drop, so which causes a voltage drop for all the appliances connected to the same line. Okay, connected to the same line, and which is not desirable. So to limit the starting current, 3-phase induction motor are started by means of starter. So this is all about the necessity of starter. Thank you.